All right, so this video is going to be all about slope of a line. So slope, assume for the majority of you, is something that you have heard of before, but it's probably just a review that you've forgotten over time. So we're just going to review what slope is. All right, so we can do the next thing about graphing lines and more stuff with lines. So slope of a line. All right, what is slope? Well, let me just draw a few lines. They're not going to be perfectly straight because I can't draw well. All right, but if you think about these lines as hills, all right, like hill that you're walking up, there's different steepnesses to it. So this blue line is going to be harder to walk up than this red line, and the red line is going to be harder to walk up than the green line because the green line is downhill. So the slope of lines just gives us a way to talk about the steepness of it. Right? Is it going more vertical? Is it going pretty flat? Or is it almost going straight down like a mountain or something like that? So slope is just a way to talk about the steepness of the line, and every line is going to have some steepness to it, so we can kind of define this word slope. All right, the slope formula is something that you kind of just have to memorize, all right, but there's all these other little tricks and sayings to kind of help you figure it out. One thing to note is that the letter M is almost always going to represent slope. So in a equation we'll see later, and when we represent M in different situations, M is just the shorthand for slope. All right, so that's just a letter. Mathematicians like to be lazy, so we just have a letter represent this concept of the steepness of a line. All right, so how do we talk about the steepness? I'll look at the middle one first. So we're going to look at the change in the y values. How much is this line going up and down versus the change in the x values? How far is it going left and right? All right, so that's kind of the basic definition. We're just looking at the change in the different coordinates, and that's what we talked about plotting points already. All right, but the change in the y value, we just take the second y value and subtract the first y value. That gives you the difference in the y values. And same idea for the x's, those little numbers, it just means the second x value minus the first x value. And where are these x values coming from? Well, if we have some line, we can take a point here and a point here. This is my first point, so my first x and y value. This is my second point. And that's where these things are coming from. So the first x value, the second y value, that kind of thing. And we'll do examples in a second. All right, so that's really useful when you have numbers that you're working with. All right, you plug in whatever this number is right there. You plug in whatever this number is right there, and so on. All right, one thing that's going to be helpful with graphs is instead of having this numerical formula you have to work out, we're going to have this other way of thinking about it. And that's rise over run. So just like we said, the change in y is the change in how much we're going up and down because it's the y direction. That is the rise of your graph. So how much is the graph changing in the up and down direction? That goes on the top there. And the run, all right, the next part is the change in x, how much I'm changing left and right. That's going to be the run, just like you run in a straight line on the ground. So if you take the rise over the run, that's also going to give us the slope. So all these things mean the same thing. It's just that this one will probably be more useful if you have numbers, and then this one will be more useful if you have a graph. And that's exactly what we'll see when we start doing examples. All right, so for these examples, we want to find the slope of the line between these 2 points, 2, 4, and 3, 7. All right, so our slope, our formula, you can look back at the last slide. Hopefully have it written down in your notes. All right, but that's our formula. And now we just need to plug in everything that we know. So y2 is the second y value, so I'm going to put a 7 there. y1 is the first y value, so I'm going to put a 4 there. x2 is the second x value, 3. And x1 is the first x value, 2. All right, and remember all our points are x comma y, so that's how I'm using the second number for the y's, the first number for the x's. And then it's just simplifying. 7 minus 4 is 3. 3 minus 2 is 1. And when we're talking about fractions, we know 3 divided by 1 is just 3. So the slope of this line is 3. Now the next one, we're going to do the exact same thing, same formula, same thing. The only process is we have these negatives, so we just have to be a little bit more careful. But starting out, we still have our formula. y2 is our second y value, so negative 6. I'm going to subtract the first y value, 3. Let me erase that little in there. second x value is 4. And I'm going to subtract my first x value, -2. And then again, we just simplified -6 minus 2 is -9. They're both negative, so they're gonna, well, we're taking a negative and subtracting a number, so it's gonna get more negative. Here we have 4 minus -2. Generally, I'd put parentheses around this, so I know it's -2 and not subtracting 2 or something. But we know when we have this double negative, these negatives cancel, and that's the same as adding. So subtracting a negative is the same as adding, and that gives me 6. And we already talked about in our fraction unit how to simplify fractions. It's going to be -3/2, because both of those are divisible by 3. All right, so our final answer is just -3/2 is the slope of the second line. All right, so these are our two answers. All right, so you can see when you just have these kind of numbers without any other information or graphs, all right, this formula here is really useful. So this is something you kind of just have to remember. All right, but kind of this kind of other references to it, change in y over change in x, rise over run. All right, so here's your chance to try your own. All right, find the slope between these 2 lines, or sorry, 2 points. And here's the solution I got. So slope formula, plug in the numbers, simplify, you get -1. So again, compare this to what you got. Maybe you made a small mistake with a negative or something, you can kind of figure that out. All right, if you can't figure out how I got my answer and your answer is different, all right, make sure you ask a question so you can figure this out before you keep going through the video where we do different stuff with slope. And so now the only difference we're gonna do is instead of being told information about the line, we're actually gonna look at the line and try to figure out the slope. So we had our formula that we used in the last examples. I have it back on that second or third slide. We also had this rise over run definition. So remember, rise is how much you're changing in the up and down direction. Run is how much you're changing in the left and right direction. So if we're gonna look at this blue line first, the first thing we do is identify 2 points on our line. And you could say pick this one and this one, but I don't know the exact value of that second point that I made. All right, so I wanna try to be precise and pick points that are actually on the kind of crosshairs of numbers. So another point looks like that one's an exact point. All right, so those are exact whole number points on my line. And I can take the line to get between them, but I want to know the rise and the run. So the rise is how much do I have to go up or down between these points. So to get from that point to that point, I have to go up 1. And then the run is how far I go left and right. I have to go 1, 2, 3, 4. Right. So for my blue line, my slope is the rise, I had to go up 1, and the run, I had to go right 4. I'm just gonna do the same thing for all these ones. So this one, let's see, it looks like there's a nice point there, and another point, let's say there. And again, you're looking for points that are just on the crosshairs because you know those are the exact whole numbers. And I look at the rise, 1, 2, 3, 4, 5, 6. So my rise is 6, and my run is 1, 2. All right, so the slope of my red one, rise of 6 over run of 2. And I can simplify that fraction and get the slope of that one is 3. And then the last one, the green one, again, let's try to find our points. There's a crosshair there and there. So my run, so my lines are always going from kind of left to right. So to actually get from this left point to this right point, I have to go down 2. So that means my rise is gonna be -2. And then I run 1, 2, 3. So the slope of this green one is -2/3. All right, so keep in mind you're going from left to right, so you might have to go down instead of up, but going down just means your rise is a negative number. And you'll start to see patterns like these lines that are going in the upward direction. Those have a positive slope, and this green line, which is going down that direction, has a negative slope. So those are ways you can kind of check yourself too to make sure your rise over run makes sense. All right, and here's one to try on your own, find the slope of this line. And here's my solution. You go up 1 over 3 between those points. Again, you could have picked different points. You could have picked these 2. I'm going up 1 over 3. You could have picked the outside 2. I'm going up 2 over 6. but that also simplifies to 1/3. So there's a lot of ways to do these problems, but 1/3 is the slope you should have gotten. And multiple choice question, all right, figure out the slope of this line that goes through 3, -6, and -1, 2. All right, so it's similar to the earlier examples where you need to use the formula, but use these points to figure out what the slope is.